Okay, please pay attention. This is winter 25 4-2 variant. Question number 1. Magnesium nitrate and strontium nitrate both decompose when heated to form the metal oxide and a mixture of gases. Write an equation for the thermal decomposition of magnesium nitrate. When nitrates decompose, they form respective metal oxide, nitrogen dioxide, and oxygen gas. Right? So, and this is the ratio, 2 moles for nitrogen dioxide and half mole for this. State which of the magnesium nitrate, strontium nitrate decomposes at lower temperature. Right? Explain your answer. The compound that decomposes at lower temperature. What is the compound that decomposes at lower temperature? That is magnesium nitrate, because it is less stable. Right? And why it is less stable? Because magnesium ion has a smaller cationic radius, or as you said, I can also write that thing, or more charge density. I think this is what you are supposed to say. उससे क्या होता है? It causes, yes, it causes more polarization of anion, more polarization of nitrate ion, hence less stable nitrate. हाँ, वो भी लिख सकते हैं. You can write which causes the weakening of internal bonds of nitrate. Okay, that's an additional line which you can add on. Magnesium oxide and strontium oxide both react with dilute sulfuric acid. Both are basic oxides. When they react with acid, they are going to form salt and water. Magnesium oxide forms a soluble salt, which is magnesium sulfate, we know. And strontium forms insoluble salt, which is strontium sulfate. Because both of them are basic oxides, so when they react with sulfuric acid, it forms MgSO4 plus H2O. Similarly, strontium oxide, when reacts with the sulfuric acid, it forms strontium sulfate plus H2O. Now, the question is, identify the product for magnesium reacts with the sulfuric acid. So what is the product? Yes, magnesium sulfate. You can write the formula or name. Explain why A is more soluble than B. Why magnesium sulfate is more soluble than B? We all know that magnesium is on the top, strontium is down there. So as you go down, what happens? Yes, and why it decreases? Because the cationic radius. Yes, it results the increase in cationic radius. If this is magnesium ion, strontium ion would be like this. Increases, sorry. When cationic radius increases, what happens? Both delta H of lattice and hydration decreases, but the decrease of hydration is significant, is more, right? This results delta H of solution from exo to endothermic, right? So that is the cause, right? So cationic radius increases. Down the group, or you can also write the alternate words. Strontium ion has more cationic radius than magnesium, right? What happens? As a result of this, delta H hydration and delta H LATT decreases, but delta H of hydration is more significantly decreases and becomes less than delta H LATT in case of strontium sulfate, turning delta H of solution from exo to endo, hence insoluble, from exothermic to endo, hence water insoluble. Ethanol reacts with nitrogen dioxide. The products of the first step of this reaction are CH3CO radical and the molecule of nitrous oxide, HNO2. Use the two words to explain, to complete the sentence. This reaction involves what? Homolytic fission. We learned this in AS that when the covalent bond breaks, and the shared pair of electron is equally divided, then free radicals are formed, and that type of bond breakage is known as homolytic fission. So homolytic fission takes place, and as a result, the hydrogen atom mentioned in A1 forms a covalent bond with one of the oxygen atoms of NO2, one of the oxygen atoms of NO2. So hydrogen has to bond with oxygen. Please mind this. An NO2 molecule has a single unpaired electron on the nitrogen atom. All electrons are paired in HNO2 molecule, right? Dot and cross diagram for NO2, right? So keep in mind two things. He has given you a hint that hydrogen must be bonded with oxygen. And the second thing which you have to keep in mind, the nitrogen and oxygen both are period 2 elements in the periodic table. Their outer shell is the second shell, so they cannot expand their octets. So you have to draw the dot and cross, in which you have to complete 8 electrons, not more than that, in their outer shell. So in case of NO2, for example, here is nitrogen, here is oxygen, right? Nitrogen has how many electrons in its outermost shell? 1, 2, 3, 4, 5, and then let's say 6. So we can say, okay, fine, nitrogen has 5 electrons, so nitrogen can share 2 electrons with this. Here it is. So I made a double bond between nitrogen and oxygen at this moment. That completes the uh, octet of oxygen. And nitrogen has how many electrons now? Nitrogen has total 5. So 1, 2, 3, 4, 5. So I can make a dative bond with this oxygen. Yes, that's possible. So let's make a dative bond here between this nitrogen and oxygen here. It's a dative bond. So in this way, because he has given you a hint, there is a one unpaired electron. You see on the top, he said there's an unpaired electron on the nitrogen atom in NO2. Okay, so that's why that gave me a hint. Okay, we can make this dative covalent bond with this. So this is NO2. You don't need to draw this arrow. I just explained it to you. That's why I'm drawing it, right? So you simply draw it like this. So this is NO2. In HNO2, come to HNO2, bacho now. Here. So if you come to HNO2, he told us the hydrogen atom mentioned in A1 forms a covalent bond with one of the oxygen atom. So there must be nitrogen bonded with oxygen and then hydrogen bonded with oxygen. So it should be like this. For example, let's start. Hydrogen has 1 electron here. So 1, 2, 3, 4, 5, and 6. So in this way, hydrogen's doublet is complete by making single bond with this, right? And if oxygen shares 1 electron with nitrogen, so nitrogen has 1, 2, 1, 2, 3, 4, 3, 4, 5 electrons, right? So now again they can share 2 electrons on this side. So these 2 electrons I'm going to share with this oxygen. I think now octet is complete for all 3, right? Here it is. Do you get it? So there is no single electron. All of the electrons are paired, and there is a single electron on NO2. So I think that's the criteria that is given to this. So that is a kind of hint. Use VSEPR theory to predict the bond angle at the nitrogen atom in HNO2 molecule. What is the bond angle in HNO2 molecule? You know what theory says? Okay, this double bond is considered as a one bond pair. This bond pair is considered as a one bond pair. So I must say I can see there are two bond pairs. Yes, and one lone pair. If there are three bond pairs, 120 का angle होता है. If there is a one lone pair, so angle reduced to 2.5 degree. So that is 117.5. You remember two bond pair, one lone pair के साथ यही angle आता था. The rate of reaction for the reaction between CH3, CHO, NO2 is shown here. The rate equation is given for this reaction under the certain condition where the concentration of both are 0.2 mole per dm cube, and the rate of the reaction is this. Calculate the value of rate constant K. Everything is given, so it's straightforward. We have the rate equation, we have their concentration, so let's make K subject. So K would be equal to rate divided by CH3CHO concentration and raised to the power 1. Both has the orders 1. So let's put in the value. Rate is 1.53 times 10 to the power minus 4. And the unit is mole per dm cube per second divided by 0.2 mole per dm cube into 0.2 mole per dm cube. Okay, now if I calculate the value comes at 3.3 times 10 to the power minus 3. Now, if you look at the units, this mole per dm cube cancels this mole per dm cube. So left mole per dm cube here. So when it goes up, it becomes what? Mole minus 1 dm cube per second. Okay. And this is 3.83 times 10 to the power minus 3. Here is the value of the K, bacho. The reaction mixture described in B is monitored over the period of time. Okay, this reaction mixture he is talking about. Predict whether the graph of NO2 against the time concentration of NO2, if you plot the concentration of NO2 against the time, shows a constant half-life. Predict whether shows a constant half-life. Explain your answer. What's your prediction? Not a constant half-life. Because the half-life can only be constant if the overall order is 1. और अगर दो रिएक्टेंट्स हो तो एक को बहुत लार्ज एक्सेस में लेना होता है. अब तो दोनों की कॉन्सेंट्रेशन 0.2 मोल पर डीएम क्यूब थी टू मेक इट ओवरऑल फर्स्ट ऑर्डर. सो नॉट कांस्टेंट हाफ लाइफ. व्हाई? बिकॉज ओवरऑल सेकंड ऑर्डर रिएक्टेंट. बिकॉज ओवरऑल या किसी एक को भी प्लॉट करोगे ना अगेंस्ट द टाइम तो कांस्टेंट नहीं आएगी. So overall, its order is second or 2, right? So जब भी आप overall order ये होता है तो नहीं कर सकते. NO2 also reacts with ozone O3. The rate equation is shown here. Under certain condition, the value of K1 is this. The reaction has a constant half-life under these conditions. Calculate the half-life. So now we have the value of K given. So we can use that formula, which is किसी को याद है क्या होता है? 0.693 divided by T half is equal to K. So if I make T half subject, so 0.693 divided by K. What is this? 0.693 divided by 0.0848 per second. So what is this? 8.2. NO2 is present in the exhaust gases of the cars. It can react with carbon monoxide on the surface of heterogeneous catalyst in cars catalytic converter. Describe the mode of action of heterogeneous catalyst. So, if you remember the heterogeneous catalyst, what they do, the reactant gases, they absorb on the surface of catalyst. You remember we said they are like this. For example, here is the catalyst. So here are the electrons. So they absorb on the surface of the catalyst. And when the gases absorb on the surface of catalyst because of the repulsion between the electrons, they are polarized. This polarization causes the weakening of bonds. And as a result, they bonds break the reactants and then they turn into the products. And the products desorb out of the surface of the catalyst. So how we write it? So लिख लीजिए the reactant gases adsorb, ADSORBD, adsorbed on the surface of catalyst due to the repulsion between electrons, the molecules polarized, and this polarization causes the weakening of bond. Right? Hence, they turn into the products. Bonds break, turn into product. The reactants, the bonds break, they turn into the products, and the products desorb. The products desorbed from the surface of catalyst. Got it? Right. So next question.